Hi, in this video, I'm going to walk you through how the counting sort algorithm works. As you can see right here, we have an array, and it's a pretty large array of 20 or 30 different values, and each value has a corresponding index. So we can see the 2 is at the 0 index, the 27 is at the 1, all the way down, and they are not currently in order. And what counting sort is going to do is it's going to actually use the location of the item, and it's going to sort it by placing that value inside of the index location. If that doesn't make sense, don't worry. I'm going to show you exactly how it works step by step. So you can see right here, the 2 value goes to the 2 index, 27 goes to 27, 22 goes to 22, 8 goes to 8. And if you can see, I'll hit pause right here, and you can see right here, the 1 value actually gets taken and into this array we're storing it in. It adds it to the location of where the one index number is, and it stores it right there. And one thing you also may notice is it doesn't actually store, if you look at the entire array, it doesn't store the value, it just stores the count of that number. So if we had 10 2s, then we would have a number 10 right here. We wouldn't have the number 2. So this is simply a count, which is one of the reasons why it's called the counting sort algorithm. So continuing it on, we're going to go through the entire array, and for each one, we're going to take the value and place it inside of the index of the corresponding array that we're sending it to. And so we're going to take this down all the way down the line, and it's a great way to organize the data. Now, while this is working, keep on watching this one. It's important to know with the counting sort algorithm that it does not work for all data types. In fact, it actually is usually used more as a subroutine in other sorting algorithms, such as radix sort, or sorts like that. So it's not one for all, but it does in certain scenarios. It works quite well, mainly because it's easy to analyze. It only uses for loops. It doesn't actually use recursion or anything like that. Okay, so now it's done, and so now you can see we're actually going to iterate through this new array. So you can see we're going to be able to have the values, and then here we're going to start incrementing it up. So where it was 5 and 8, now we have 8 and 8. 8 plus 0 is 8, so we put 8 there. 8 plus 1 is 9. We change it to 9. 9 plus 0 is 9. 9 plus 0 is 9. Once again, 9 plus 0 is 9. In 15, it's going to be 10. This is going to be 13, 14, 14 again, and it's going to be 14 for all of these because it's only incrementing up by 0. And then on the 22 index, you're going to see it's 16, then 19, then 20. And as you can see, all it's doing is it's counting up and taking the total number inside each item of the array, and it's adding that. So you'll see when we get to the very top that the last one is going to be 30. Okay, and now all we have to do is take these numbers from the right to the left. There you go. And see, this is the final step of the counting sort algorithm. Once again, as you can see this, the complexity on this is it's not going to be similar to the other ones like quicksort or merge sort, where it's O of n log n. The complexity of this is actually O of n plus k. And so it's quite a different type of solution, and it's the reason why it doesn't work for all data types. So as you can see right here, we're going and we're actually finding the value, and we're associating that value. You can see the 11 is going to go to the 11th index. It's going to take the 8, and then it's going to put the 11 at that index value. We'll see the next one. We take the 23, go to the 23 index, take the 17 from it, go to the 17th index, and then put 23 inside of that new in that new value. So as you can see, this is not the most straightforward algorithm in terms of the way it works process-wise. However, if you actually follow along and you play with some data and see how it works, you'll see it actually does work quite efficiently for certain data types. I'm going to pause after this next one and we're going to walk through it. Okay, so in this one, you can see we had the value 28, and it was in the 9 index. I'm sorry, 28. So we had 28 here at the index of 9 in the original array. So all we had to do was look to the 28th index of this array, and we saw that that was 23. And so we take the 23, go to the 23 index of the new, our final output array, and we take that 28 and put that inside of that value. And so we'll, I'm going to hit play and go through a couple more, and then we're going to analyze it again, because at least for me, this was not the most intuitive solution for sorting the first time I tried it, but after you go through it a few times, it actually does make quite a bit of sense. Okay, on this one you can see we had a value of 28 again, and it was at the 4 index. And so this 28, we just simply had to look. We only have to look at one item. It doesn't really matter what the index is here. So we took the 28. We know that that 28 is going to be representing the 28th index, which has a value of 22. We take this 22 and go down to the 22nd index of the final array, and then we simply dump the 28 value right into it. So it's that part of it's pretty simple, and if you look at this visualization, I think it's very helpful, because where it was 28, that is circled in dark blue, and where it's 22, it's circled in light blue. So the main thing to know about counting sort is how you take the original value and you have that directly connected to the index value of kind of your middle array, the one that you're doing a lot of the processing and the counting on. And then you use that index value to look up whatever the actual value is stored inside of that array element. And then that is the index of the final array. And then you essentially swap them. So where 22 is the value in the array at the 28th index, in the final array, it's just going to be swapped. So it's going to be the 22nd index, and it's going to have a value of 28. Keep on going down the line. We'll have 8, and we know that goes to the 5th value, and you put that 8th in there. 27 goes to 27th, points to 21, and we know 27 goes there. And that's it. We now have a fully sorted array. If you look at it, we have 1, 2s, 4, 8s, 11, 15, 16s, 17, all the way down the line until 30. So it's perfectly sorted, and we used it using the counting sort algorithm. So this one is one, I did not get this immediately. It took me a few times and playing around and actually watching the visualization quite a bit. So please let me know if you have any questions with that whatsoever, and I will see you in the next video.